All right. We are almost done with the lessons for this week. You can do it. This one is about comparing fractions. So figuring out which one is bigger, which one is smaller. Sometimes we use less than, greater than, or equal to. Sometimes it just might ask which one is bigger, and you can just write the bigger one. Now, there's some different ways we can do this. The first way is to draw a picture. Sometimes all I need to do is draw a picture and it will become very clear which one is bigger and which one is smaller. But sometimes that can be tricky because if you're like me and sometimes your drawings are not exact, then it's hard to tell, or lost my train of thought. So sometimes it's just hard to tell if they're really close together, it can be hard to tell. So sometimes we need to write equivalent fractions, or write fractions with the same denominator. Okay, so write equivalent fractions that have the same denominator in order to compare them. So I'll go over both of those ways. So first way, say I have 2/3 and 1/2. Now, if I draw, I do need to make sure that the two things are the same length. So 2/3, I'm dividing into thirds. Okay, so 2 of them versus just 1/2. Even if your art skills aren't quite exact, it should be pretty obvious that 2/3 is bigger, so 2/3 is greater than 1/2. Now, you could also go back and use these, and they're halves and thirds, so we can see, sorry, scared myself. So if I have 2/3 versus, 1/2, okay, well, 2/3 is bigger. Okay, so if you're not sure about your art, there's another way to do it. Now, if I have 5/6 and 1/5, this one you might not even need to draw, because you might say, okay, if I have 6ths and I have 5 of them, that's almost the whole thing. Almost. Not quite. 1/5 is only one piece out of 5, so that's almost 0 if I was going to think back to rounding it to benchmarks. So 5/6 is definitely bigger. So that's another way I might not even need to draw it. I always could draw it, but I wouldn't necessarily even have to if I can picture it in my mind. If I did want to draw it, obviously that is an option. Or I think this one has 6 and 5ths. So 6 and 5ths, I could drag out 5/6, drag out 1/5, and see which one is bigger. Whoops, wrong tab. Now, sometimes it's a little harder. Say I have 3/4 and 7/10. Okay, it's not obvious right away which one is bigger. Now, I know the number 7 is bigger and the number 10 is bigger, but does that mean that 7/10 is bigger? Let's see. Now, if I draw it, okay, here's my 4ths, that's 3 of them. Here's 10ths, oh goodness, 10ths are hard to draw. 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 1, 2, 3, 4, 5, 6, 7. Okay, those are pretty close. Now, 3/4 looks bigger, but it could just be my drawing is not very good. So I don't always want to rely on that. So let me show you what I have to do sometimes. Sometimes I need to write them with what we call a common denominator. So 4 and 10 are not the same denominator, right? Well, I want to rewrite these. What's something equivalent to 3/4? What's something equivalent to 7/10 that has the same denominator? So to do that, I'm going to think about, okay, what are my multiples of 4? Okay, those are some multiples of 4. I could keep going. Here are some multiples of 10. Okay, I found one that is the same. So I need to pick a multiple of both that is the same. Then I can write my equivalent fractions. What did I multiply this by? I multiplied that by 5 and by 5, so I get 15. This one I multiplied by 2, so I get 14. So I can see, okay, 15 twentieths is bigger than 14 twentieths, so 3/4 is bigger than 7/10. Let me show you another example of that. I also want to point out that, look, 7/10 was not bigger. Even though 7 and 10 are bigger, 3/4 was actually the bigger fraction. It was more of the candy bar or the pizza. Say I have 5/8 and, what do I want to do as my second one? We'll go with tenths again on this one. And then if I have 6/10, which one is going to be bigger? Okay, this is going to be another one where if you try and draw it, it's just going to be hard to draw. So I want to think about, first of all, I need to find a common denominator. And I do that by listing multiples. Don't worry. If it's not making sense this lesson, we'll do this all the time with adding and subtracting. So I'm going to list my multiples. 8, 16, 24. If you need to pull out a multiplication chart to do this, go ahead. Okay, then 10, 20, 30, 40. Oh, look, 40 is the same. So I'm going to rewrite them both with 40. Now I need to, I'm going to multiply. I'm going to write equivalent fractions. So I need to think about 8 times what is 40, because that's the denominator. Well, 8 times 1, 2, 3, 4, 5 was 40. So I do this times 5 as well, and I get 25. This one is times what? 1, 2, 3, 4. So I do this times 4, and I get 24. So 25 40ths is bigger than 24 40ths. So I'd put my symbol that way. Didn't mean to put all the bigger ones first, but you know it happens sometimes. So again, I'm more than willing to help you with this. Just let me know if finding equivalent fractions is still feeling challenging. That's okay. We will be practicing this a lot when we get to adding and subtracting fractions. Now, most of these ones are ones that you could draw a picture and figure out. And if you get stuck on the other ones, let me know. Remember also, if you're having trouble reading it, click on that text-to-speech, and it will read it for you. Okay, it should work right away. If it doesn't, let me know. The code word for this one is the. It's another boring one. And sorry, you're going to have to wait until next week to find out the next word in the sentence. I'm going to leave you hanging. So it's the today. Good luck. You got this.